This is covering 4.2, part 2, which is just graphing log functions, and 4.3, properties of logs. So 4.2 is just graphing and finding the domain, and then all of these properties. Do y'all recognize these rules? Product rule, quotient rule, power rule. That comes from exponents. But remember, exponents and log functions, they are inverses of each other. They have a really big relationship. So these rules are really similar to the exponent rules. So let's first look at graphing exponential and log functions. So f of x equals 3 raised to the x power. We graphed this, I guess it was last unit. Not unit, but we've graphed this before, I feel like. So 3 raised to the x. This was the exponential function. So this would be 3 raised to the negative 2, which would be 1 over 3 squared, which we reduce it down 1/9. We're going to keep it as a fraction because that's the exact. We don't want to approximate. Then to the negative 1 power, so 3 to the negative 1, just 1 over 3, bless you. Then if we have 0 as our x value, we plug that in. 3 to the 0 power is just 1. And then when x is 1, we have 3 to the first power, which is 3. Oh, which is the same thing right here. So we've already created this table. So what we are going to do to find the log function, because these are inverses of one another, we're going to flip our x and y's. So reverse coordinates, x and y. So you can do the exponent, the exponential function, and then you can reverse it to find the other values. So here, we're going to reverse it. So the x value is going to be 1/9. What matches with 1/9 is negative 2. When the x is 1/3, it's going to equal negative 1. When x is 1, it's going to equal 0. And when x is 3, it's going to equal 1. We're going to look at how that is graphed. So for the 3 raised to the x power, negative 2 was at 1/9. I'm going to graph these. And then negative 1 is 1/3. 0 is 1. And 1 is 3. So we know that exponential function is a smooth curve starting at your x-axis, because that's your asymptote, and it has a smooth increasing graph. So this one is the f of x equals 3 raised to the x power. It's the exponential function. So we're going to graph the log function, log base 3 of x. So whenever we did those, we have 1/9 is negative 2. So our x value is 1/9 down to negative 2. See where I graphed it? And then 1/3 down to negative 1. and then 1, 0, then 3, 1. So this is also going to be very similar with that smooth increasing curve. So instead of our asymptote being the x-axis, it's going to be the y-axis right here. Then you make a smooth curve, and it's increasing. So this is g of x equals log base 3 of x. What's cool about inverses is that y equals x, that basic linear parent function, is what they're reflected across. So if I were to draw my linear parent function, which is through the origin, slope of 1, that is what they're reflected across. Okay, so on this, the x values, which is your domain, it goes from infinity to negative infinity to positive infinity. So negative infinity to positive infinity, because it's going to go to the left to negative infinity, right to positive infinity. But on the log function, it's going to be at 0, and then it's going to go to infinity. So the asymptote on this one is the y-axis, when the asymptote on the other one is the x-axis. They're flipped. They're reverses of each other. So your domain and range are actually flipped as well. So whatever the domain and range is for this, you're going to flip them to find the domain and range for this one. Okay, so these are characteristics of the log functions in the form of log base b of x. For the domain, it's going to be from 0 to infinity. And the range is negative infinity to positive infinity. But the value of x, if there's another constant being added or subtracted to that x, that's going to change your domain. Log base b of 1 equals 0. So we have the point 1, 0, but there is no y-intercept. And the reason is because it's never going to cross the y-axis. Okay, so it's increasing and it goes to the right. And then it goes down to the right and is decreasing if the b value is between 0 and 1. And then the y-axis is our vertical asymptote. Okay, so let's look at the domain of the function. So the way that we find out our domain is by looking at the value log base b of something. We want to look right here, and we want to find out all the values that would make that equal to 0, and we want to exclude those. So this g of x cannot equal 0. So this is how you can find what you're excluding, by setting it equal to 0 and listing out those numbers. So we're going to look at the domain of log base 4 x minus 5. So the base is 4, so that falls in this category. where the graph goes to the right and is an increasing function. Let's look at this and see what values do we need to exclude. We're going to set it equal to 0 because it can't equal 0. So where x equals 5, that's where it won't work. We have an undefined, we have an error. So that's where the asymptote is. So this is your asymptote. And that's going to tell us how the domain is going to be restricted. So let's go ahead and draw our asymptote as a dotted line on the graph. So our log function will never cross that. So this provides us with our domain restrictions. So our domain is going to be greater than 5. So we can write it as the interval form, 5 to infinity, with parentheses around it, because it'll never touch 5 and it'll never touch infinity. So we know it's going to be an increasing function because this log base 4, and it's going to go to the right. So we just need a couple of points. We can actually put this into the graph. So let's go ahead and get our calculators out, and then we'll graph it on here. So let's look at y equals. If you need to get a calculator, they're over there. Or if you have your own. All right, do y'all know how to get log in our calculator when we go to y equals? Where do we go?
Math, maybe?
Well, there's log, but whenever we put that in, it's just going to be base 10. But I want to change what the base is. Alpha, one of the alphas. Alpha, like window or something? No. Which one?
It's alpha 5, yeah.
Alpha window number 5. So see how that looks? Number 5 is log base, parentheses, and then has a spot for the base and for the value. So let's go to 5. So log base 4 of x minus 5. Then we can hit graph to look at it. So let's go to our table of values. So it's going to be, say, 6, 0, 7, half. Let's go 9, 1. Just kind of like that. So it can get closer and closer to 5 without touching. All right, let's keep on going. Common log functions. So anytime we have a log function without a base, we assume it's 10. That's our common log function. Some other things that we need to know is the natural log ln of e raised to the x is going to just equal x. Then if we have e to the natural log of x, that's also going to just equal x. If we have the natural log of 1, that's going to equal 0. So that's ln, natural log. Ln of e is going to equal 1. So we're going to use these to help us simplify log expressions. So let's look at our first rule, the product rule. So we have a log base b, and then inside the parentheses is m times n. So what we can do is expand it out, and we're going to add log base b of m plus log base b of n. So anytime these are multiplied, you're adding. Similar to exponents. You remember the exponent rules? Okay, so let's look at these examples. Log base 6 of 7 times 11. So we'll rewrite this as log base 6 of 7 plus log base 6 of 11. We can't simplify that any further, so we're just going to leave it like that. Let's look at the next one. This is 10x. So we can separate into log 10 plus log of x. Or log 100, sorry. Plus log of x. Log base 10, we can think of this as 10 to the what power gives us 100. Second. So remember how we did this yesterday? 10 to the x equals 100. So x equals 2. So that's what this is. 2 plus, we can simplify this down. 2 plus log of x. Okay, the quotient rule. If you have a log base b and then 2, like a numerator and divisor, then you can separate those out into subtraction, into the difference of the log. Okay, so 23 is divided by x. So we're going to separate this out as log base 8 of 23 minus log base 8 of x. And there's nothing we can do there. So when you're finding the quotient, you're subtracting the logs. Okay, let's look at the next one. Ln of e to the 5th minus ln of 11. We could use one of those properties from that last page. Ln e raised to the x just equals what the exponent is. So this is just going to equal 5. Okay, the power rule. If you have a log base b of something raised to a power, we can take that power out front and it'll be our leading coefficient. So we take the exponent and put it out front. And it's p times log base b of m. Then you see if you can simplify it. So let's look at this one. We have a power of 9, so we're going to take that out front. So it's going to be 9 log base 6, 3. And there's nothing we can do there. Okay, the next one we have a cube root. We need to be able to write this with an exponent instead. So it's going to be ln x raised to the 1/3. So you can use these same rules on natural logs. So we're going to take that 1/3 out front. Okay, the next one. I'm going to take this 2, take it out front. So 2 log x plus 4. Nothing more we can do there. Okay, we're going to learn how to expand and condense log functions or log expressions. So this is just a review over the different rules. All right, I have a cube root of y. I want to get rid of that. But I also have 2 things being multiplied. So could I actually separate those? How do you separate whenever the 2 things are being multiplied? You add them. So it's going to be log base b of x cubed to the 4th plus log base b of cube root of y. Okay, what else can I reduce here? Or simplify, expand? Which one? This one? Okay, so what can that be? Yeah, so log base b of y to the 1/3. That's an exponent. Kind of doesn't look like it, but that is an exponent. What can I do to this one to expand it? Yeah, let's put the 4 in front. So 4 log base b of x. Okay, what else can I do to simplify it? Yep, move that 1/3 to the front. So 4 log base b of x plus 1/3 log base b of y. Okay, the next one took a little bit more room than I had right here, so you're gonna have to write small or maybe write on that other page. I think I'm gonna write it over here so I have plenty of room. I'm gonna rewrite it. Log base 5 of the square root of x over 25 y to the 3rd. You can't see mine. There we go. This gives me a lot more room because I didn't have enough room while I was doing this earlier. All right, so how can we separate things out because we have division? Subtract. So we're going to write this as log base 5, the square root of x, minus log base 5 of parentheses 25y cubed. Okay, what do I need to do with the first term? What's the square root? Not negative. Oh, should this be? No, that's right. Yeah, 1/2. Log base 5 of x to the half power. There we go. So square root is the half power. If it was a -1, it'd be the fraction. Okay, what else can I do with this? Let's go ahead and just simplify this one. Move the half out front. So we have half log base 5 of x. Okay, so we're done with that. So let's do something with this guy right here. Okay, this is multiplying, isn't it? What do we need to do with that? If you have multiplication, how do you separate it out? Add, yeah. So it's going to be log base 5 of 25. Oh, I need to put this in parentheses. Plus log base 5 of y cubed. Okay, look at 5 and look at 25. They're related to each other, right? Because 5 squared is 25. So this log base 5 of 25 is 5 squared to equals 25. So this right here becomes 2. Because if I were to rearrange it, 5 to the x equals 25, like we were doing yesterday. There we go. Equals that x. So I would simplify it. 5 to the x equals 25. X equals 2. So that's what I'm going to put right here. So minus 2. Okay, and then this is going to be minus this. But is there a way I could simplify this?
3 front.
Yeah, 3 out front. But it's going to be minus because I need to distribute that negative. So minus 3 log base 5 of y. Yeah, a little bit of work there.
So last thing?
We're almost done. All right, to condense, we're going to do the opposite. Instead of having a plus or minus or the number out front, we're going to take it the other way. So let's go here. Log base 10, because there's no base there, equals 25 plus log, or plus log 4. I don't even know what I'm saying anymore. Yeah. So whenever we have the same base, we can multiply those numbers. So it'll be log of 100. So it's log base 10 of 100, which 10 raised to what power gives us 100? 2. So our answer is just 2. Okay. Log base 10 minus log base 10 of something else. What operation do I do whenever this is subtraction? Division. So we're going to write this as log, and it's just 10 of x plus 6 over x. Nothing we can do there. We're going to leave it. All right, last one. Last one. Yay. All right, so natural log of x plus natural log of 3. What do we do with that? It's addition. So what do we do with our two values?
Multiply.
Yeah. So it'll be of 3x. And we're done. Yay. All right. And your last assignment is on Pearson. Besides your review, but you know.